Today I'm gonna talk about how to do the derivative of a composite natural log function. For the derivative of natural log function, we have the formula that is ln x prime equals 1 over x. Okay, so if we have a composite natural log function, what is the derivative? So let's take a look. The formula ln fx, okay, that is composite function prime, that should be 1 over fx. Okay, this part should be very similar, 1 over fx, and derivative of fx or fx prime. Okay, we're gonna follow this formula to solve the derivative of a composite natural log function. Let's take a look. The first example, ln x squared plus 2 and find the derivative of this guy. So the first step, we need to identify what is fx, because we want to follow this formula. So we have fx here is fx equals x squared plus 2, right? That's the fx. Okay, very good. We find the fx. Then we can follow the formula 1 over fx. 1 over fx, that is x squared plus 2. And then do the derivative of fx. Plug in fx, that is x squared plus 2 prime. And then we can simplify it. We have the derivative for each term, right? And the derivative for the polynomial, that means we're gonna derivative for each term. And for the first term, we just follow the power rule, right? Power rule 2x 2 minus 1, and the derivative of a constant, that is 0. And we can simplify. Here's 2x, and the denominator gonna be x squared plus 2. Okay, now let's take a look. The second example, ln 3x squared plus 2x, and we're gonna do the derivative. And the first step, we need to identify the fx. Fx equals 3x squared plus 2x. And we already find the fx equals 3x squared plus 2x. We just plug in the formula here, 1 over fx, that is 3x squared plus 2x times the derivative of fx, plugging the fx here, prime. Okay, now we can simplify it. We're gonna follow the sum rule. We do the derivative for each term. And we're gonna get what? And for the first term, we have constant, multiply x squared. We just extract the constant. We just do the derivative for the x terms, right? And the same thing for 2x. We have constant 2, we just extract the 2 from this term. We have derivative of x. Okay, and we almost get it. And this term we're gonna follow the power rule, and the derivative of x gonna be 1, right? And then we can simplify it, and we're gonna get the denominator 3 times 2, 6 times x gonna be 6x, and 2 times 1 is 2, divided by 3x squared plus 2x. Okay, now let's take a look the last example. Len 2x to the power 4 plus 3e to the power x. Okay, so again we need to identify fx. For this guy, fx is 2x to the power 4 plus 3 times e to the power x. And now we're gonna follow the formula to calculate the derivative of this guy. Okay, calculate the derivative of this guy and plug in the formula. 1 over fx should be 1 over 2x to the power 4 plus 3 e to the power x, and then times the derivative of fx. Fx is 2 times x to the power 4 plus 3 e to the power x, and we can copy it, and derivative of these two terms we can use sum rule, right? We do the derivative for each term. We do the derivative of the 2x to the power 4 plus derivative 3 times e to the power x prime. Okay, and then we're gonna evaluate these two terms. For the first term, we have a constant 2, right? We just move out. Actually, we do the derivative of x to the power 4, right? And for the second term, we have constant here, right? 3 times e to the power x. We just extract the 3 out of this function, and we do the derivative only for the e to the power x. And then we can simplify it. For the derivative of x to the power 4, we can use power rule, right? Power rule. And the derivative of e to the power x is itself. Okay, we can simplify and we can find the numerator gonna be 2 times 4, 8, and x to the power cube, or x cube, and here is 3 e to the power x, ex, divided by 2 x to the power 4 plus 3 ex. That's it.